Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, Chemical Kinetics. This is the fourth chapter. Last class I have finished electrochemistry. Now I am going to start fourth chapter, that is chemical kinetics. What is the chemical kinetics? What do you mean by the word kinetics? Kinetics means motion, movement. Here you know that in chemistry, by its very nature, chemistry by its very nature is concerned with change. Substances with well-defined properties are converted by chemical reaction into other substances with different properties. For any chemical reaction, chemists are very interested to know three things. First things, the feasibility of chemical reaction, which can be predicted by thermodynamics law. Thermodynamics law. How will come to know that reaction will take place or not? Then that can be predicted by thermodynamics. That is that delta G must be less than 0 at constant temperature and constant pressure. If delta G value is less than 0, means negative at constant temperature and pressure, then you can tell that reaction can take place. These things already I have discussed in details. Second things, extent to which a reaction will proceed can be determined from chemical equilibrium. How much reaction will take place, extent to which a reaction will proceed can be determined from chemical equilibrium. This also I have discussed in details in chemical equilibrium chapter. Third things, a speed of a reaction, that is a time taken by a reaction to reach equilibrium. These three things are very, very important, and chemists are interested to know all these things. Then here only feasibility means possibilities, whether reaction will take place or not. Along with feasibility and extent, it is equally important to know the rate and the factors controlling the rate of a chemical reaction. For its complete understanding, these things are required. For example, which parameters determine as to how rapidly food gets spoiled? How will you come to know that food will spoil? This how will you conclude that food will, how fast, how rapidly food gets spoiled? How you can determine, or how determine as to how rapidly any materials, that is the setting material for dental filling. If you have tooth problem, then sometimes that actually in dental problem, if you go to the dentist, they want to fill that gap. Sometimes in gap a hole will be there and it will be very, very trouble for the patient. Then they fill by some chemicals. Then how fast it will work, because there you need quick recovery. Then how will you come to know that in how much time that this hole in your tooth will be, you can say, recovered, problem will be solved, because that earlier by filling that gap by chemicals your problem will be solved. Then how will you get this idea, or what controls the these things rate at which fuel burns in auto engine? How will come to know that rate at which fuel burns in an auto engine? How will come to know that you are starting the car, motorcycle, anything, then what happens there? How much time it will take to start the engine? Correct? Then many things are there you have to understand. All these questions can be answered by the branch of chemistry which deals with the study of reaction rates and their mechanism, called chemical kinetics. Means how fast reaction will take place, how slow reaction will take place. Different type of reactions are there, they react differently. Some will be very slow, some will be very fast, some will be some reactions will be intermediate, moderate, and some reaction will be so fast you can't imagine also. In 10 to the power minus 12 second, picosecond. Some reaction takes place in picosecond. Means in 10 to the power minus 12 second, in fraction of second. Then see this rate of reaction. Particularly this reaction, what I have told you now, that some reaction takes place in 10 to the power minus 12 second. This reaction takes place in our eye. In our eye, that many chemical reaction takes place and change takes place in fraction of second. Then how all things we are knowing? Then we can know only by a study of chemical kinetics. Food digests in our body. Anything, many things are there. You know that in our body many reactions are going on. Our life is full of chemical reaction only. Then some reactions are very slow, some reactions are very, very fast. Life itself, you can see, from the newly born baby to, you can say, old man. This is also, this stage, different stage in our life is due to the chemical reaction, change in chemical reaction. Even the final death also, that this chemical reaction is responsible. Their reaction, they determine our life, natural death, this chemical reaction. Then for all the things, that to study all the things, to know the rate of the reaction, if you want sometimes to control the rate, some poisonous gas is coming out from anywhere, how will you control? Then or sometimes by mistake someone will take poison, then how will you control it? How will you this poison, how will you that effect will be controlled? How? Many questions are there related to this reaction, that is only you can get answer by a study of chemical kinetics. Even people know that diamond you know till date, it is the strongest substance on the earth. Majority of people thinks that it is always it will be diamond, but it is not the truth. It can convert into graphite. Diamond can convert to the graphite, but its reaction is so slow, it is very difficult to tell the time. Then some reactions are so slow. Some reaction, as for example, you might have seen in a lab, if you are mixing silver nitrate solution to the sodium chloride solution, simply you will add, as soon as you will add silver nitrate in NaCl solution, you will get white precipitate of silver chloride. Very fast, just you add, you will get the precipitate, white precipitate. Then this reaction is called fast reaction. Have you seen the sand near the river? Particularly I am talking about the long river Ganga or other rivers near the mountain. You have seen the sand, white. How much time, how it became that sand with so much small particles? How? This is the particles of mountain, big mountain, a strong mountain, that converted in a natural way into this form, particle form. Due to the weathering, rainy season time, then it takes a very long period to convert from that big stone. Strongest bond is there, very strong bond, to break that bond and convert into the particles form. Rusting, you might have heard the name of rusting, iron rusting. Already I have discussed last class. Corrosion, corrosion. Then see, corrosion also takes place in rainy season. Iron if you will keep, then within 10-15 days, you will find these things, brown color. Brown color is due to the rusting of iron. Correct? Also called corrosion in general. Sometimes you will find black rusting. Black rusting in old building, if you will see the window, if there any rod is there, iron rod, then you will find black rusting. Then how much time it took? Then all things, all answer you will get by a study of this chemical kinetics. Correct? Then name itself has been given chemical kinetics. Means that reaction you are taking, you know that all slips, electron never slips. When you are sleeping, that time also electron does not slip. Always it will be moving. Even in solid, any solid, you take any example, either you take iron, a stone, any strong, what do you think? All things are stable there? No. If you will go through, then you will find, you know that all things are made from the atom. And atom consists of electron, proton, neutron. Mainly, many other particles are also there. Then from the outside it looks that it is a solid, nothing is moving. But fact is that inside the atom, electron is there. Electron always will be moving everywhere, wherever it is. Either in solid, liquid, gas, anything. It never slips. Even after the death of the person, that body decomposes. If you will keep, you will not do anything, then how many you can say this body will decompose and many life again it can form. Then chemical reaction does not stop. Correct? And electron, there is no question. Then this movement always means you are talking with atom and molecules. If any reactions are going on, then they will be in the molecular form. Reaction generally takes place in molecular form, molecular state. Then here reaction First, to understand the chemical kinetics rate of reaction, the word rate is common. What you know that in market you are going or asking rate of any vegetables, any grain. Rate is the same way here, meaning is same, but a rate of chemical reaction. Then how will you determine the rate? How will you understand the rate of the chemical reaction? Then for that you have to understand one term that you are all knowing, already I have discussed, that is the concentration. Concentration. Generally reaction takes place in liquid form. Okay. Generally reaction takes place in liquid form. Solid form it will not take place, or if it will take place it will be very very slow, very slow. Okay. Then there you have to know what is the concentration of that solution. Liquid means here solution, and solution means here solid plus solute plus solvent. Solute plus solvent is equal to solution. Example, you know, solute as for example NaCl, sodium chloride. If you will add in water, water is a solvent, universal solvent, then it will form solution. Then now suppose in a beaker you have taken 100 ml water, in that you have added 5 gram sodium chloride, correct? Other beaker 100 ml water and now 10 gram sodium chloride. Third beaker 100 ml water, 15 gram sodium chloride. Then see, all three type of solution have different concentration. Different concentration in that 5 gram in 100 ml means per liter how much? Then 1000 ml means 1 liter. Then 100 in 100 ml 5 gram. Then in 1 liter how much? 50 gram. 50 gram per liter. And in second one 10 gram you have added. 100 ml 10 gram. Then that will be 100 gram per liter. Like that way, third one how much? 15 gram you added in 100 ml. Then now in 1 liter how much? 150 gram. Correct? Then you see now they all three solutions are of different concentration. Then the concentration means mole per liter. How many moles present in 1 liter of solution? That is called concentration, mole per liter. Then how you will convert the mole? Gram you are knowing, NaCl, that is the gram. Sodium you have taken in gram. Then how will you convert into the mole? That also I have already discussed. Mole means what? Weight divided by molecular mass. Then here 50 gram you have taken, then 50 gram divided by NaCl. Then NaCl, what is the molecular mass? How will you calculate molecular mass? Then I will add the atomic mass, means atomic mass of sodium plus atomic mass of chlorine. Add it, means sodium 23, chlorine how much? 35.5. Add both, then you will get molecular mass. Then weight divided by or mass divided by molecular mass of the substance, that is called mole, number of moles. Then in a easy way you can tell what is the concentration. Then concentration, it is a common way, I already told you, it is expressed in many ways, but one common way here which you have to know in this complete chapter, That way only you have to know. In solution chapter already I told, I have expressed concentration in different way, many ways. Then now here moles per liter, how many moles are present in 1 liter solution, that is called concentration. Okay. Then now here chemical kinetics, your intention is to know the rate of reaction. Then reaction will take place. How reaction will take place? Then reaction takes place between two solution, at least two solution. Now suppose you have taken solution A, other is solution B. If you will mix both A and B, then after the reaction it will give new product. Correct? Maybe sometimes only one product it will give, sometimes two product it can give. Then A plus B, suppose reacted, then it will give, suppose two products C and D, C plus D. Correct? Then here you have to understand example, already just now I told you, silver nitrate, AgNO3, liquid form, not in solid. Even solid is there, you have to make solution in adding in water. Then silver nitrate plus NaCl. Then silver nitrate plus NaCl, both are called reactant. NaCl is reactant, and silver nitrate is reactant. Two reactants are there. After mixing, it will give only this what product will be there? AgNO3 plus NaCl. Then it will give two product. What are the two product? Then silver chloride, AgCl, one main product, and other product will be NaNO3, sodium nitrate. Correct? AgNO3 plus NaCl. Then you know that it will go to the positively charge. Na is positive charge, cation. In silver nitrate, silver is cation, Ag plus. NO3 is minus nitrate, that is called anion. It will react with NaCl. Na is positive, cation. Cl is negative, anion. Then both reactant will react, and then each ion will go to the opposite charge ion. Means positive will go to negative. Means Ag plus will go to the Cl minus. It will form AgCl, precipitate. It can't will be suspended. It will be settled down because it is heavy. It will settle down. It will give white precipitate. You can see. And another product is what? NaNO3, sodium nitrate. Then it is soluble in water, that you can't see. Because it is soluble in water, you can't see. But silver chloride is insoluble. That's why it will settle down, or you can see it in the form of precipitate. Then this I have told you the reaction only. Then in reaction actually what happens? This is the fast reaction, quickly it reacted. Okay, after just I will add and it will give the product very fast. But some reactions are not fast reaction. It will be slow. As for example, I am giving you very interesting example. Sugar, common sugar, or glucose you can also tell. Common sugar, sucrose, which you are using daily in your home. Sucrose. With tea you are adding that sugar I am talking about, sucrose. That is C12H22O11. When this will react, this if you will mix it with H2SO4, sulfuric acid, correct? Sucrose plus sulfuric acid, concentrated H2SO4. If you will mix, then what will happen? Then this reaction is in very several ways. It is very interesting. See, sugar looks very its color is white. Its color is white, correct? But how much carbon daily you are eating now by this reaction you can understand. If anybody will tell, will you eat carbon, then you will scold him. What you are doing, how carbon I can eat. But now here you can see carbon you are eating daily in the form of rice, wheat, sugar, many things, but not in a direct way, in indirect way. Then here you can see when both will react, sugar plus concentrated sulfuric acid, if you will add, suppose 5 gram sugar you have added, or 10 gram sugar you have added in 100 ml H2SO4, then what you will find? You will get as soon as you will add, reaction will start, and you will find fumes. 3 things you will find that time. First, you will see that white fume is coming. Okay, effervescence. White fume will come, and after 1-2 minutes, 3 minutes, you will find that you are not able to touch the beaker. Suppose you have mixed in beaker, because beaker is becoming hot, warm, and in the beginning it was sugar was white, but slowly you will find that now sugar color is changing. It is turning towards light yellow, and after 15-20 minutes, you will find now in beaker, you can say 2 things are remaining, means it will be in the form of liquid, but one will be dark black substance. Main substance product will be black, complete black, and that liquid is water, because C12H22O11, then H22O11 means 11H2O, and C12 means carbon, 12 carbon. That's why in reaction you will get product 12 carbon plus 11H2O plus heat, 3 product, carbon plus water plus heat. Then because it was the warm, that what you have seen the fumes, that was actually of this water. Then now you can see this 12C, main product was the carbon, and other product was H2O, water. Third product was heat, warm. Then now you can see it took 30 minutes around around 30 minutes it took that time to convert into the for the complete reaction. For complete reaction it took time, roughly 20 minutes, 25 minutes, depending on the how much you have taken this sugar quantity. Then see, this reaction taken too much time to give the product. Rice, you have seen in kitchen, it takes time to completely cook it. Correct? Rice, any vegetables, it takes time to cook it. If you will not alert, then rice will be also black, and vegetables will be also black. Anything what you are cooking, that will be black. Then why it is becoming black? Now you can understand. Correct? And why this always vapor will come? Then now you are also understanding that is a water vapor. That water you have mixed, that is different things. what was the water present in that grain, that also will come out. Correct? Vegetables. In vegetables, what you are purchasing, that water is there. That's why if you are cooking, then it will come. Vapor will also come, and slowly it will change. Many color it can change into many color. Finally, if you will not alert, it will burn completely black. That is happening due to that complete reaction, and it is giving final product carbon only. Then here I wanted to tell you, this is very important reaction example. Here many things you can understand. One important things I want to tell you, because question is asked that why it took 30 minutes or 35 minute times. Why not like silver nitrate? Silver nitrate solution and sodium chloride solution you have mixed. That reaction taken part very quickly. Why not this reaction like that way, same way? Why it has taken time? That is very, very important question is asked. And here you have to understand, almost all organic reaction will be, you can say, slow. Sometimes it takes 10 hours time, 15 hours time, 24 hours time to take place. Correct? It will not go fast. Then why? What is the reason behind that? Then its main reason is that organic compounds have many, you can say, many bonds. As for example, this reaction, what I told you, C12H22O11. 12 carbons are there. C12H22, 22 hydrogen is there, 11 oxygen is there in one molecule. In one molecule, this number of bonds are there. Correct? In one molecule of sucrose, this number of atoms are present. Then all are joined with bond, covalent bond, all are joined with covalent bond. Then it takes time. It takes time to break all bonds, and after that it takes time to make new bond. That's why it takes more time for the reaction. Okay. Then this I have told you why it is taking more time. Then now rate of reaction, we come to the rate of reaction. Then here what will happen, that during the reaction, suppose A plus B in general way, it is reacting. Then A concentration of A and concentration of B both will change with the time, because reaction they will react and it will give the product. Then in the beginning, suppose you have taken A, you have taken 10 mole per liter, 10 mole per liter. B also, B was suppose 15 mole per liter. Then now when both will react, then now A concentration will decrease, B concentration will also decrease, because both will react. Then A will be also used, B will be also used. And suppose it is forming two product, then same time it will make two product C and D. Then as soon as A and B is reacting, that time only, that moment only, simultaneously they will form C and D product. Okay. Then here you can say how much concentration of A decreased, how much concentration of B decreased in the same ratio, or you can say in the same way, they will, you can say, form the products, two products. Okay. As for example, now you can see that silver nitrate and sodium chloride. Then here you can see both are concentrated. One that concentration of silver nitrate is decreasing, but reaction will be fast. That is different. But now silver nitrate, its concentration will decrease, NaCl concentration will decrease, and quickly it will form these two products. Same time, that because that reaction is very fast, correct? But other reaction which is slow reaction, that also will form same time, but quantity will be very less. Quantity will be very less. Concentration of A will decrease slowly, concentration of B will decrease slowly, and C and D will form in the same rate, same way. Correct? Then how much you will come to know the rate of the reaction? Then by this change only. By this change of only, change of concentration with time. Change of concentration with time. By that way you can understand the rate of reaction. Then suppose in a general way I am talking about that C1 was concentration in the beginning, and after some times, suppose A concentration was C1 in the beginning, and after some times you can say its concentration became C2, means less. Then what is the difference now? In concentration, now 10 mole becomes 6 mole, then 4 mole difference, and suppose that difference took place in 5 minutes, then divide by 5, then per minute how much concentration changed, that is called rate of reaction. 10 mole now it is remaining 6, means 4 mole now reacted in 5 minutes, then 4 divided 5 mole per liter, per time, per unit time, means per minute, correct? 5 mole per liter per minute, that is the rate of the reaction. Then this is the concept I have told you, okay? And like that way, if you want to know the B concentration, then same way for the B you can understand how much its concentration decreased. And same way product side, because as soon as both will react, that time only both will give the product, both product will get. Then rate will be rate of reaction of these things, left side reactant rate of change of reactant, means it decreased, rate of the reactant will decrease, correct? Both reactant will decrease, and same time product side rate of that product will increase. Same way, here it is decreasing, there it is increasing, hence the rate of formation of product will increase, and both rate will be equal, rate of decrease and rate of increase of product. Rate of decrease of concentration of reactant is equal to the rate of formation of product. This is very, very important. Means rate of change or rate of decrease in concentration of A is equal to rate of concentration of decrease of concentration of B, both are equal. Correct? Decrease of concentration of A, rate of decrease of concentration A and rate of decrease of concentration B, both are equal because both are reacting same time. In same time both are reacting. Correct? Then rate in the same ratio, whatever is there, they will react. Then decrease will be rate of decrease of A and B will be equal. Okay. Now product side also rate of formation of C and rate of formation of D will be equal because they are forming only from the A and B. Then in general way you can know the rate of decrease of A is equal to rate of decrease of B because both are decreasing here and product side it is increasing. New product they are forming, new things are there forming. Then all four rate will be equal. But only difference that here it is decreasing and that side it is increasing. Then minus you can write for the decrease. For the decrease you should write minus sign for the decrease. Then always from change you can write from the final minus initial. Then suppose in the beginning I told you C1 was the in the beginning concentration and final concentration is C2 after time t, suppose after time t. Then final minus initial C2 minus C1 and time divided by time you can write, or T2 minus T1. At that time T1 initial concentration was there and final time T2 C2 concentration was there. Then C2 minus C1 divided by T2 minus T1, final minus initial. Correct? Then obviously you will find minus 10 mole, now it became 6 mole, 6 minus 10, final minus initial. Then minus 4 mole per minute it is changing. When its concentration changed, 4 mole per minus 4 mole per liter, that concentration changed in 5 minutes. Correct? Concentration mole per liter, always remember concentration divided by time I told you. Then concentration is mole per liter, minus 4 per liter divided by time. But product side it will be plus. It will be plus sign. Means now product you got, that will be, you can say, as for example, that was concentration was this things. It was in the beginning it was G0, now it became C3 because product you got from 0 you got C3 product. Then difference C3 minus 0, that is a C3 plus. Then concentration divided by time. Time will be the same everywhere. And that will be plus. Other product same way. Then rate will be equal for all four. For a reactant side both and for product side both. Rate of the reaction will be same. Rate of decrease equal to rate of formation of product. Increase. Rate of decrease of concentration is equal to the rate of formation of product. One side it is decreasing, other side is increasing same time. Correct? Suppose you are from one container, one glass water you are adding from one container to the other. Then what? Through the pipe, suppose or if this water also, suppose you are taking and quickly you are adding, then they are decreased, here increased, same quantity, time will be that same time only taken and added. Like that way you can understand. And I think you have understood that all rate all rate will be equal. Correct? Rate of decrease of A is equal to rate of decrease of B equal to rate of increase of product. C is equal to rate of increase of product D. All are equal. All are equal. Then this is a very conceptual things I have discussed. Okay. Then in actually this I told you about the rate. How actually sometimes reaction will take place in gaseous. This I told in liquid form. In the liquid form. But some reactions will take place in gaseous state. Then how will you measure that things? Their concentration. Then that is this concentration is directly proportional to the partial pressure of the gas. Partial pressure of the gas. Suppose gas A and gas B was there. Then gas A has some pressure, gas B has some pressure. After mixing they will create total pressure. Total pressure. Then in that sense, in comparison to the total pressure, pressure of A is called partial pressure. Means A divided by total, pressure of A divided by total pressure of A and B. Like that way, partial pressure of B is equal to partial pressure of B divided by total pressure of A and B. Correct? That is called partial pressure. Then now in the place of concentration, pressure term is used. Okay. Then now for the gaseous reaction, one theory is there called collision theory. Collision theory of reaction. Collision theory of reaction rates. Okay. Then that theory is only for gaseous reaction. Then all things, and on what factor rate of reaction depends? Then rate of chemical reaction depends upon concentration, temperature, pressure and catalyst. Four things are there. Rate of reactions depend on temperature, pressure, temperature of the reaction, pressure of the reaction, temperature, pressure, concentration and catalyst. Then how they are affecting, that you will study here in details. Okay. And that also at the macroscopic level we are interested. At the macroscopic level we are interested in amounts reacted or formed and the rate of their consumption or formation. Actually macroscopic level means big size, and molecular level means a small size. Then at the macroscopic level we are interested in amounts reacted or formed and the rate of their consumption or formation. At the molecular level, the reaction mechanism, what we will understand by molecular level. Then at the molecular level, the reaction mechanism involving you can say orientation and energy of molecules undergoing collisions are discussed. That is discussed. Okay, at molecular level, because the mechanism you can understand only at molecular level. Then how they are you can say collisions are taking, how they are colliding, what is their orientation. One from the direction, orientation means from which direction molecules will collide, how they will in which direction they will make the bond or break the bond. That orientation means particular direction. How, in which direction, how they are just reacting from back side, front side, like that way. Orientation means always that how direction is related to direction, front side, back side. Okay, like that way. Left side, right side, down, up. Just like any things are in atmosphere, it can react from every direction. Like that way, orientation. Then this I have told you about the chemical reaction background I have given. Then here already for the reaction we use the term, for the reactant we use the term R, and for the product we use the term P. Okay, and for the time we use the term T, a small t. Okay, and for the concentration we use the term big bracket, molar concentration. As for example, if A you are writing in a big bracket, capital A you are writing in a big bracket, then you can tell it as a molar concentration of A. And if it is B you have written in big bracket, then you can tell molar concentration of B. Like that way, R you can write in bracket, big bracket, then molar concentration of R, or simply concentration of R, concentration of P. P means product. You can tell like that. Then here you can write like that. Suppose in the beginning time was, in the beginning suppose it was a T1 time, maybe 0. T1 you can tell. Final temperature is, final time is T2. Then change in time will be delta T. T2 minus T1, that is called delta G. A small, less like a triangle, you know, delta T. Delta T means difference of T2 minus T1. Like that way. Now suppose in the beginning, suppose reactant has concentration R1 concentration, means R you have written in the bracket, and after time T2 its concentration became R2, means R you have written the bracket, and R2 minus R1, that is called delta R, change in concentration of reactant, delta R. Then now this product, same way you can write P2 minus P1, means in bracket you have written P, initially P1 and finally P2, then P2 minus P1, that is equal to delta P. Then now you can write the rate of disappearance of R. Suppose reaction is going on, then rate of disappearance of R, means reactant, that is equal to decrease in concentration of R divided by time taken. Then decrease in concentration of R means delta R divided by delta T. Okay, this is the rate of disappearance of R. Same way rate of appearance of P, means product, it will form the product. Then what will be the product? Then same way increase in concentration of P divided by time taken, that is equal to delta P divided by delta T. Then rate of appearance and rate of disappearance both will be equal. Then only difference is that rate of disappearance means decrease, that will have minus sign, means minus delta R divided by delta T, and rate of appearance will be positive, plus, means plus delta P divided by delta T. Okay, since delta R is a negative quantity, as concentration of reactant is decreasing, it multiplied by or it is multiplied with -1 to make the rate of the reaction is positive quantity. Okay. If you want to tell that rate of the reaction, then you have to multiply by -1, then you can tell in the positive way. But actually is minus is the or decrease and plus is the increase for the product. But you can multiply, you want to tell in the term of positive, then -1 you have to multiply, otherwise leave it. Then now by graph also you can understand. Graph is very, very important. Then here just you can take, you can draw a graph, concentration versus time. Concentration versus time. Time you can take on x-axis and concentration of the reactant you can take on y-axis, perpendicular, vertical. Okay. Then concentration of reactant versus time. If you will draw the graph, then you will find nature of the graph just like you can tell that football you have seen, and now suppose football you have cut it only from the what you can tell, one side you have cut diameter, diameter. From the beginning you can cut, then is a diameter. Okay, it will look like 50-50. Watermelon you are cutting, then half spherical. Then like that way, if you will see one part of the sphere down, you can see down to up to the cutting, it will that shape. But here you keep just it will be that's what you can say, from the up to down. If you see, then you will find that concentration is actually it will look like a curve, correct na? Then from the upside it is touching the vertical line is there, y-axis. Then in the beginning, because in the beginning means time is equal to 0, x-axis time is there, then come to the beginning 0, and just you are starting how product how you can say reaction is going on. Then in the beginning no reaction will be there at 0 time. Then at 0 time means at the beginning concentration of reactant will be 0. It will be as it is. It has not decreased. In the 0 time, no reaction. Then reactant will be full. Full reaction will be there, no consumption, no use. And as the time will pass, then slowly now concentration will begin to, reactant will begin to decrease. Concentration of reactant will begin to decrease. And if you will write many points how they are decreasing with time, then you will find that it is just like a curve, not a straight line, curve. What I told you in that shape only. You have cut a football or any sphere in two parts. Then outer part you see, that type of curve you will get. At a different time you will get, you can say different points. Suppose concentration will change with time, then it will look like a curve. And on this curve, by this curve also you will see that when reaction will be means reaction will complete, or you can tell when it will come in equilibrium position, then that time it will be parallel. Curve will not touch to the x-axis. It will not touch to the x-axis. It will be above only, just like a parallel. Then any time if you want to know the rate, then you can make a right angle triangle. Means what? Just to start from the curve and go little down, parallel to y-axis, little 1 inch 2 inch, like that you can go down. Okay, down parallel to y-axis means vertical, and again from the this here, suppose 2 inch you went down, 2 inch, 3 inch, just simply I am telling you, just you went down, and after that, from that parallel to x-axis, again you go, then it will touch the curve. It will touch the curve and it will take a shape of right angle triangle. It will take the shape of right angle triangle. Then now right angle triangle, that is a tan theta. Tan theta is equal to perpendicular by base. Then perpendicular will be that y-axis. Then now just you have gone to, I told you 1 2 inch you went down. Then now what is the exact value of reactant? Because y-axis, from the y-axis you want to know this value, perpendicular value you want to know from the y-axis, reactant value, how much changed. Then suppose from R1 down went to R2, then R2 minus R1, that will tell the value of this perpendicular P, okay, that value R2 minus R1, and down time you want to know. Then now you can see in the beginning it was the T1, and when it has touched the curve, because parallel to y-axis and parallel to x-axis were drawn two lines, small line. It took the shape of triangle shape, right angle triangle. Then perpendicular value came to know by the parallel way. You can see what is the value R2 minus R1. Like that way time you can know the T2 minus T1 from the x-axis, because that base is parallel to x-axis. And the T1 at T1 and at T2, what is the value? T2 minus T1, that you are knowing. Then T2 minus T1, that is for base. Then P perpendicular value you are knowing, and base value you are knowing, P and B. Then just to put the value, you will get the value of tan theta, that is known as slope, S-L-O-P-E, slope, correct. Then like that way, this is called actually rate, average rate you can tell. This is called a small r. R means rate of the reaction, that is denoted by r, small r. Then this is the called average rate, R A V E, in shortcut you can write R average, that is equal to minus R2 minus outside in bracket R2 minus R1 divided by delta T. Then this value you are knowing, means slope value you are knowing, tan theta value, and that tan theta, that is the slope perpendicular by base, but it is a negative sign outside because concentration is decreasing. Then rate is equal to slope minus slope, and slope is equal to tan theta, and tan theta is equal to this delta r minus delta T, or sometimes D also you can use a small d, difference, dr divided by dt. For the change, d is also differentiation term d, that is can use here. Then dr divided by dt, that is equal to slope minus slope, that is equal to rate. Slope is called rate, correct. Then this I have discussed you. Same way, this you have seen, this graph I have told you in case of reactant. In case of reactant it is a decreasing. But if you will want to know rate in term of products, then products, what will happen? With the time product will increase. Then now reverse of nature of the graph curve will be reverse. It will be just like a swelling nature, upside. From the zero from the 0 time, slowly and slowly this product is increasing, hence it will go up. Okay, with that time it is going up, and it will again it will take that curve opposite of the reactant. Now because it is increasing, product is increasing, it will go up, but first one was down. Curve was just opposite in appearance. Correct? Same way, concentration here concentration of product divided by time plot you are considering. Then now same way, if you want to know the rate, then you can that inside the curve you can make same type of right angle triangle. Right angle triangle means just 2-3 centimeter or inch just to draw parallel to y-axis, and again you have to draw the parallel to x-axis. Then again it will take the form of it. It should touch to the curve. Only near the curve you start. From the any point of curve you start the straight line parallel to y-axis 2-3 centimeter, and then parallel to x-axis you start from the curve. It should cut the both lines should cut. You know that this parallel to y-axis and parallel to axis both line will cut. It will take a shape of right angle triangle. Then same way p value and b value you can get it, but here all thing will be the same. Slope only tan theta p by b. Then p value parallel to base, parallel to this y-axis. Product value will get, and reactant value, time value will get from the x-axis. Then delta p upon delta t, but here it will be positive because product is increasing, that's why plus sign. Then here same way, rate is equal to average rate is equal to delta p upon delta t. You can tell delta t upon delta t or dp upon dt. Then now I am stopping only here. Next class I will go in details. Other things I will discuss. Thank you.